When he exposed patients to cowpox to prevent smallpox, Edward Jenner discovered cross-reaction, the basic principle of immunization. 100 years later, in the 1890s, it was discovered that although tetanus and diphtheria were deadly infections, it was really the incredibly lethal toxins made by the bacteria that did the damage. You couldn't immunize someone with tetanus toxin. Even a tiny dose would be fatal. But it was possible to modify the toxin so that it was harmless, though it looked to the immune system very much like the real thing. Antibody made against harmless toxoid protects against lethal tetanus toxin, the second most poisonous biological substance known. So we added tetanus and diphtheria toxoids to the list of vaccines. In immunization, the term herd immunity is important. It is the fraction of people in a population that must be immune so that the disease will not spread and become an epidemic. When there is little immunity in the herd, the disease easily spreads from person to person. When herd immunity is high, it's difficult for an outbreak to get larger. The more infectious a disease is, the higher herd immunity must be. Measles is one of the most infectious diseases known and requires 95% immunization to achieve herd immunity. Even with herd immunity, if an unimmunized child is exposed to measles, he or she will almost certainly get the disease. Unfortunately, in Europe especially, many people have been misinformed that the measles vaccine is dangerous and refused it for their children, leading to a dreadful, ongoing, and completely unnecessary measles epidemic with tens of thousands of infections in the last few years. About 1 in 1,000 children who get measles will die from it. We have a lot of vaccines, both for humans and domestic and farm animals, but smallpox and rinderpest in cattle are the only eradicated diseases. If we could stop having wars, we'd be rid of polio and measles by now. We don't have vaccines against HIV, the AIDS or SIDA virus, nor a really effective tuberculosis vaccine for both children and adults, nor against the parasite that causes malaria. And we could save many lives with an influenza vaccine that was needed only once, but protected us against all major strains of the virus. A lot of research is going into these very important diseases, and I hope we will eventually be able to prevent them too. We like to think about our immunity, especially to virus infections, as the 3 lines of